The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon and welcome to this July webinar. My name is Robert Bruce Long and I'm with the U.S. Department of Energy Better Buildings, Better Plants program. I'd like to welcome you to the special edition of the Better Buildings webinar series. In this series, we profile the best practices of Better Buildings and Better Plants Challenge and Alliance partners and other organizations working to improve energy efficiency in their facilities. Today's webinar, entitled Mission Complete, Outcomes from the Challenge to Develop a $100 Wireless Submeter, will present results of the DOE's low-cost wireless metering challenge that engage electronics manufacturers to produce a cost-effective, accurate wireless system capable of measuring various electric loads within a building and wirelessly communicate the data. On May 15, 2017, the DOE recognized wireless technology company Meson for their exemplary performance in meeting the specifications. Although Meson is the only company to meet the specifications so far, the performance specifications stand as an opportunity for other organizations to enhance the market for low-cost submetering devices. Today's panelists will discuss the challenge and the wireless submetering technology that won the contest. As many of you are aware, submetering is very important in order to accurately measure where energy is going within a building or a manufacturing plant. However, traditional wired submetering instrumentation may not be doable due to inadequate cable infrastructure and limited input-output availability. This is why wireless submetering devices can be a very good option. In recent years, the submetering technology has become much more sophisticated and easier to install in remote locations. This makes it possible for a wide range of building owners, plant managers, and maintenance staff to understand where they are using energy and to help keep their energy costs in line. In today's webinar, we will discuss all these benefits. We will also have a couple of polls to help us understand how the market is approaching this topic, so we do ask that you all participate in these polls. Lastly, we will wrap up with a question and answer session and remind everyone about some upcoming events within Better Buildings. Before we get started with our presentations, I want to remind our audience that we will hold questions near the end of the hour. Please send in your questions through the chat box on the webinar screen on the right side through the session, and then we'll try to get to as many of them as we can. Also would like to remind you that the session will be archived and posted to the web for your reference. Next slide, please. So today's presenters are going to be presented in two different batches. Myself is your moderator, and then Ann Wagner with the Pacific Northwest National Laboratory. Before we get to Ann's presentation, we're going to start our first poll right now. So question number one, have you ever submetered? Please select one of these answers and we'll give everyone about 10 seconds. Okay, and we have the results so far. Looks like 62% said yes and 38% said no. Great, thank you very much. Next question. The next question is, are you considering submetering in your facilities? Aha, and we have an answer so far. 97% of y'all are saying yes. Wow, excellent. Next question, please. What is the biggest obstacle in implementing energy submetering? So please select all that apply. Okay, and we have some results so far. Just a very small number don't see the benefits. Some people have said that submeters are expensive and big. Hopefully you'll have a different understanding after today's webinar. Installation and effort and other costs are high. And I would argue that this is actually a real concern, especially if you need to have an electrician come in and install, the cabling infrastructure and all that. Energy monitoring applications are expensive. That's probably more true in the past. I think the cost is coming down. That was part of the challenge to see if we could make it more cost effective for folks. And I think you'll gain a better understanding of that after today's webinar. And then lack of expertise and resources to analyze the data. That's where we come in. We're providing these webinars, and we're developing new resources. We'll show a couple of websites about the DOE's challenge where you can get some more information on this. Okay, so next question, please. Okay, so that was the first poll. I want to thank everyone for participating in today's initial poll. And today, now I'm going to present Ms. Ann Wagner from the Pacific Northwest National Laboratory. Ann is an energy efficiency engineer with PNNL in the building sciences area, where she supports energy technology development and implementation projects. While working with the U.S. DOE's Building Technologies Office, she has been involved with several of their challenges, including the Wireless Metering Challenge and the High Performance Rooftop Unit Challenge. She also supports several DOE campaigns and programs aimed at increasing new technology applications, including the interior lighting and the lighting energy efficiency in parking lot campaign. And additionally, provides support to the U.S. Army Reserve's Energy Resiliency Program. As a mechanical engineer, Ann has worked over 25 years of experience in buildings industry. Prior to joining PNL, Ann worked with utility energy efficiency programs and in the commercial building HVAC arena. Ann, go over to you.
Thank you, Bruce. Thank you, Bruce. Today, I'd like to share with you a bit about the Wireless Metering Challenge effort. So you can go ahead to the first slide, please. In my portion of this webinar, I'll provide some information regarding the objective of the project, giving you some background as well as discussing the process and results. I'll conclude by summarizing several of the lessons learned from this work. Next slide, please. $120 billion. That's the cost for electricity consumption of commercial buildings in 2012. And this is a screenshot of the CBEX data. It helps give context when we discuss the Better Building Alliance's focus on reducing energy cost. Next slide, please. First, I'd like to highlight the fundamentals for reducing energy use. Our focus with the Wireless Metering Challenge was on the measurement of electrical energy consumption. But no matter what energy you're considering, you need some essential information. You first need to establish a baseline so you know your starting point. Whether you're using actual data from measurements or creating a simulation, your first step is to acquire data. The second step is to analyze your information. And finally, in order to reduce energy use, you must take action. Next slide, please. Today, we're addressing the type of metering commonly referred to as submetering. This slide provides the GSA definition that submetering is the application of metering technology below the level necessary for utility billing. In other words, a submeter can measure the energy consumption of a whole building at the panel level, at the system level, or even at the device level. Next slide, please. How did the Wireless Metering Challenge get started? Well, several years ago, the Department of Energy recognized the benefits of submetering systems. These include getting information on energy use, not only to determine baseline operation, but to see the effect of any system changes or adjustments. They also realized the benefits of continuing to monitor energy use to confirm persistence of savings. DOE installed submeters in the Forrestal building and had a bit of a sticker shock. They determined that the installation of each submeter cost thousands of dollars. DOE realized part of this cost could be attributed to the hardwired communication system. With the requirement to reduce energy use in federal buildings, DOE recognized that the high cost of installing submeters could be a concern across federal agencies, and so the wireless metering effort began. Initially, we talked to representatives from many federal agencies to determine their essential metering requirements. Additionally, we received input from the private sector. Then a specification was developed. Next slide, please. On June 16, 2013, the Wireless Metering Challenge was issued. This challenge included 3 primary requirements: low cost, measurement of electrical energy, and wireless data transmission that would not use any existing building networks. Next slide, please. Following the launch, 30 manufacturers indicated interest in participating in the challenge. Of those, 9 submitted product information, including feature descriptions and product cost. Of those, 3 companies provided information that both met the technical requirements and offered equipment that was close to the cost target. 2 manufacturers provided the required documentation for accuracy testing and UL certification. Then, 1 company moved to the final stage, which was the testing of their system's data transmission within an actual building. Next slide, please. The intent of the spec was to just require features that were essential in order to keep the cost down. In other words, we developed a specification that would incorporate the technical requirements needed to support energy management in real working environments while balancing cost considerations. This table, we've noted several of the key system specifications in the left column, with the primary benefits of those requirements in the right-hand column. For example, the spec requires measurement of watt-hour energy consumption for a 3-phase circuit to provide actual measurement instead of just calculating the energy as some metering systems do. The requirement for the reading accuracy of the device, coupled with the sensors, allows a deviation of 1% compared to a revenue grade meter that only allows a 0.2% deviation. While the 1% requirement is not as tight as a revenue grade, it should be good enough for practical energy management. Also, this allows for a lower cost than if the requirement is for revenue grade accuracy. Data security is important, so both data encryption using at least 128-bit advanced encryption standard and a communications network that is independent from any facility's network are spec'd. Next slide, please. To avoid being limited to one brand or provider, an open communication protocol was required. Several requirements helped minimize system complexity. These include requiring that the meter gets its power from either the system being monitored or the panel it's connected to. Also, only one-way communication is mandatory. Next slide, please. Once all of the documentation showing compliance, including the accuracy test reports and UL certification, was accepted, arrangements for the in-building communications test began. The test was run at the GSA headquarters in Washington, D.C. Next slide, please. The testing entailed the installation of 1 meter with 3 current transformers at a lighting panel on the 2nd floor of the building. A 2nd meter with 3 current transformers was installed at a lighting panel on the 4th floor. The slide shows one of the panels and a meter during installation. For the sensor and meter installation, an electrician is required and all safety procedures should be followed. Next slide, please. The top left picture shows a repeater. These were installed to transmit the data from the meter to the gateway. The gateway served as the collection device or base station, and it's shown in the bottom left-hand side picture, as well as circled on the right-hand side there. The gateway was then connected to the user device, which is that computer. The metering system was set up to provide measurement at 15-minute intervals for a 2-week period. We then analyzed the data to determine the communication success rate. The specification required that at least 95% of the data be successfully transmitted over that time period. The communication success rate for the system that was tested was 100%. Consequently, it exceeded the requirements. This resulted in the system successfully completing the challenge. Next slide, please. The successful technology company that completed the challenge is Meson, and you'll be hearing from them shortly. Next slide, please. Throughout this effort, we worked with a variety of folks on many tasks. It was an interesting experience, and we learned a lot. I'd like to share just a few of the key lessons from this project. A successful project requires a champion, and the wireless metering challenge was no exception. Even though the DOE project lead changed several times over the years, all of the DO leads consistently understood the potential of this effort and supported it fully. This support made the success possible. I also want to recognize the strong support that we received from the GSA staff at their headquarters building. They too realized the benefits of the wireless metering system. They were extremely helpful with the coordination and implementation of the in-building communications test. Manufacturers were reluctant to change their existing products. The first rounds of submissions included feature-rich products, which significantly exceeded the price target. When we reviewed the equipment information, we advised that these features exceeded our requirements and the product could be modified with some of those features removed to lower the price point. However, the companies declined this option. A common thread with both the large and small companies was the continuous determination of what direction they wanted to go and what they wanted to focus on. In some cases, the pursuit of wireless submetering was put on the back burner so that other business opportunities could be explored. Everyone has to consider their time, resources, and objectives. As you know, this project has taken several years. Need I say that patience and persistence were essential. Over the course of the project, companies faced challenges. The 3 companies whose offerings qualified were all small businesses. They were all developing new products, and that takes time. They experienced financial and staffing constraints throughout the process, and that extended milestone completion timeframes. Additionally, certification such as UL takes a fair amount of time. In the end, the goal was achieved, but it did take patience and persistence. The challenge addressed to technology. The intent was to spur industry to provide a system that was low cost, measured electrical energy, and transmitted data wirelessly without leveraging any networks. Today, we're happy to hear from the company that successfully met this challenge. So I'll turn it over to Bruce. Thank you.
Yeah, thank you very much, Ann. So that was a really good presentation. Thank you for clearing all that up and talking about the challenge. I now want to introduce our next 2 presenters. They are with the company that won the challenge. It's called Meson. For those of you who don't know, Meson is a Greek word, which means the maximum. So I'm sure our 2 presenters are going to give you 100% in their presentations today. First speaking from Meson is Mr. John Gionas. John is the co-founder and chief commercial officer of Meson. He has a bachelor's degree in electrical engineering and a master's in an MBA and is a technology business enthusiast with expertise in information engineering, automatic control, telco engineering, and marketing. His background is in market introduction of new business concepts, corporate governance, strategic alliances, development, and leadership of commercial and delivery organizations. Gionas worked for more than 14 years in executive positions at Ericsson and ABB. He is a graduate of Berkeley's executive program in management. Following him will be his colleague Stelios Koutroubinas, who is also a co-founder of Meson. Stelios has a bachelor's in engineering, electrical engineering, and a PhD. He's also an expert in embedded electronic system design. He once worked at Atmel, ending up as a general manager for their 150-person research and development division in Greece, where the team achieved breakthroughs in Wi-Fi chip design miniaturization for clients like D-Link, Cisco, Hewlett-Packard, Netgear, 3Com, and AT&T. Stelios is the author of 12 peer-reviewed papers and 2 patents. He also went on to senior leadership roles at Byte Mobile, working on restructuring and product design. So, John, please go ahead.
Thank you, Bruce. I'd like to start with putting things a little bit under our perspective and how we see things. Next slide, please. The next one. Energy submetering is a concept that exists several years in energy management. Connected submetering, though, in the sense of an IoT, Internet of Things wireless, mesh cloud-connected entity, having local intelligence and control capabilities and small size, is a new concept that is enabled by the latest technology advancements. An increasing trend in real estate management is the centralization of all tasks related to metering and energy management processes. Organizations with distributed portfolios of buildings find extremely useful being able to centrally manage all operations remotely and in almost real time. Installing energy submeters in areas such as heating, ventilation, air conditioning, lighting, electrical equipment, and various other electrical loads provides the organization the ability to review and evaluate their energy use strategies. They can establish energy KPIs for particular loads, as well as provide tenants with energy billing. Energy retrofits require interventions based on real data with a clear payback analysis. Smart submeters play an important role in facilitating the in-depth analysis required by owners, investors, in order to proceed with building energy retrofits. Another important application of smart submeters is demand-side response, since they can provide valuable real-time feedback of power consumption needs, enabling the utility to implement demand management strategies. These load control plans can be implemented over the same submeters that, although it was not in the scope of this challenge, this could potentially play the role of the controller. I mean, our submeter can also be a controller. Next slide, please. On the other hand, it is essential to learn how to take all the data and transform it into insights and results to improve building performance for owners, managers, operators, and occupants. This is mainly what cloud analytics do in a secure, scalable, flexible, and cost-efficient manner. Cloud is important here since there is no need to invest in expensive hardware and software infrastructures, but rather capitalize on huge existing cloud technology investments in the market. In the age of information overflow, distinguishing useful insights between bulk data can provide powerful business intelligence and support sound business decisions. High-resolution energy meters generate thousands of data points per operational day that need to be interpreted accordingly. In a single commercial building with many submetering points, various measuring parameters, and various environmental attributes, finding actionable insights in a manual manner can become a demanding and time-consuming task. The insightful findings can lead to improved operational efficiency, new revenue opportunities, and competitive advantages of significant value. Next slide, please. So, someone could safely argue then that energy efficiency is catalyzed in a transformative manner by the new building data acquisition technologies that we are talking right now, based on the Internet of Things, enabling gathering of real-time large amounts of energy and environmental data. This, combined with big data analytics cloud technologies that provide the intelligence for creating energy efficiency actionable insights, KPIs, and strategy follow-ups, can really end up in considerable energy savings and improvements in building operations and facility management. Next slide, please. So this slide looks a lot with Anne's slide. Maybe I have added a couple of components, taking into account that what we mentioned before, energy efficiency can be seen as a process, and this is how we see it, with various steps that end up enacting based on insight generated by building data acquired from the field in a systematic and analytic manner. As one of our ESCO, Energy Service Company partners stated, real-time measurement is the only way to find out how the building really works and see how our actions, such as changing the internal characteristics of a building heat pump, for example, are being applied. So the first thing that you should do if you want to reduce energy consumption is to install real-time submetering on your premises, being maybe the only way you can address the low-hanging fruits of energy efficiency, and maybe add my addition is that you can also address the high-hanging fruits, not only the low-hanging fruits. The next slide will be presented by my colleague Stelios Pitsubinas. Stelios.
Next one, please. Hello, everybody. So here we see on the left part of the slide, more or less the DOE part of the installation. We have our meters that can measure the panel where we have different loads. We can measure the total power consumption, or we can measure some of the subloads on the panel. These data wirelessly are transmitted to a gateway, and as an extension to what happened in the DOE case, this data can be transmitted to a cloud where we can organize them in properties, or we can drill down to what's happening per building or even per load. On parallel, some other tools that we have developed can be used in order to have the status of the system. Next slide, please. Here we see on a bigger detail how the panel looks like. So we have on the left the electrical panel that we want to measure things, and then we have a sub panel where we have our meters. What we need there is power. We need, in order to measure accurately, we need to have the three phases, the neutral, and then we need to, with the current transformers, to read the current value. So voltage and current can give us data for all the parameters we need to measure. We have done a very small design so it can fit everywhere, because usually there is not a lot of space available to do things. So it should be a small meter, and we have done a lot of work with this kind of configuration to simplify the installation, make things easier for the installer, and be able to control things and to fix any problems that may arise. With our devices, we can measure from, let's say, 63 ampere, which we feel is the smallest you need to measure with a three-phase meter, but we can go to thousands of ampere using Rogowski coils. As it was the requirement in the challenge, the accuracy should be better than 99%. With tests we have done, we see that the error is about 0.5%. As we said, our meters can store data internally, so there is a data logger inside. Data are transmitted to a gateway, and the gateway also has the capacity to store data at this level, but also data are transmitted to a cloud if needed, not in the case of the DOE, but on a server with different protocols. We can transmit this data for further analysis. And of course, all this on a very low total cost of ownership. Next slide, please. Why we are different? As you can see, this small meter, it includes about 6,000 lines of embedded software. Of course, in order to have an embedded system like this, And to be there and do consistent this job, it needs to be a robust system. Wireless mesh networking is necessary to cover big buildings, as the challenge was looking about. And of course, the size is really small, so that we can fit more meters and do the submetering as in the maximum, let's say, extension. The data logger and the scheduler is also some add-on features that might not be necessary for the challenge, but we can support them. Next slide, please. A few more things for our gateway. It is a Linux-based device. We can support tens of meters with this gateway. It really depends on the measurements you want to have, the distance you want to cover. I mean, having a mesh network with many hops will put extra load on the system. The parameters that you can just measure just the power, or you may want to measure frequency, voltage, current, apparent power, all the other parameters. So, and all this per phase. And then it's how often you want to measure. So all this may have some effect on the meters you want to measure on the gateway. Usually we have about 20 meters per gateway. We do local monitoring, and of course we can transmit data to the cloud. You can easily characterize the loads connected on the meters through this through an interface we have available at the gateway. It's fully configurable and controllable. The maintenance of multimeter installation is really easy based on a tool we have developed. We support demand response features through this gateway, and there is an automation workflow scenario builder available in our gateway. Next slide, please. A few more things on the cloud side now. We have what we call a software as a service energy monitoring and analytics tool. With this tool, you can have multi-branch or multi-location organizations controlled from the same slide. You have a map, you can see where the properties are located. You can select one property in the map, then you can see what meters are under this tool, and then in general you can see all the data you have stored there and try to do also other things. We monitor the data, but we can also do post-processing reports on these data. We can identify the energy trends, the baselines, the base loads, and of course we can connect online services, hardware devices, and API on these tools. Next slide, please. This is a visualization example based on Power BI. What we see here is 2 meters. It is a building. We measure the lighting in these two floors, let's say. 1 meter is measuring floor 1 and the other floor 2. What we see here, this is 2 weeks, but we start from Tuesday. As you can see, on Saturday and Sunday, the weekend is very low. Monday, it was a day off for US. It was President's Day. For some reason, the power consumption on this on one floor was much higher from the other. If we look, the rest of the week looks more or less similar to the beginning of the previous week. but then on the weekend we still see that the power consumption was much higher. Of course, all this is what the meters measured. I believe that the building management guys having more information, for instance, what is the occupancy of the building these days, could have more useful results, because if there was people in the office on the weekend, then we can say there was a good reason to have high power consumption, but on lighting. But if there was no one there, probably some lights were on without any good reason. Next slide, please. John, I think you can take the rest of the presentation.
Yes, thank you, Stelio. It's one of the two last slides. A few words about the company. We are a young company. We exist since 2012. Up to now, we have shipped around 10,000 units of these meters that you have seen in 5 continents. We have contracts that usually with large system integrators and ESCOs that they provide energy efficiency services for large multi-branch organizations. We plan to deliver another 20,000 units in the coming 12 months. The way we expand in the markets is through distribution partners and value-added resellers, and this is something that we're looking for also in the US market. Next slide, please. And in order to make things a little bit easier for our audience, the contact details, you can see them, our contact details on the left-hand side. You can do it also through our website in the contact page. We have developed 3 trial packages. One is the DOE package, and the other 2 are a little bit more advanced. We have also included some professional services, some analytic services that maybe interested companies or ESCOs or utilities could come to us, get this trial package and really see what can be done and what we can do. 2 things before I finish. The first one is that the system is open, meaning that we use our energy submeters and gateway, but we also have our own analytic and monitoring tool, but someone can use also a third-party monitoring and analytic tool. And the other one is that analytics, the way we do it, we try to capitalize on existing tools. We use today the Microsoft Power BI. We have developed an interface through our system with Power BI, so someone can use our own visualizations, our own developed, but also they can develop their own. So next slide, please. With this, I hand over to Bruce. Thank you very much.
Thank you very much, John and Stelios. This was excellent information, and I think that our audience has gotten a lot out of it. We've been collecting some questions, and we want to get to them all. I think if you can get to the next slide, I want to do a couple of things, and then we'll get to it. I mentioned earlier that we had some additional resources, and I believe these slides will be available later on for y'all, so you'll be able to see this. But if you want to do a screen capture right now, you can take a look at these links. These describe the challenge and some of the activities that went on and how it was met. And these are good resources to have in the future. Keep checking these web pages, and you'll see if there's additional technologies and companies that are available. So next slide, please. Okay, before we get to the Q&A, I believe there was a final poll that we needed to execute. If you can bring up the first question, and each one will have about 10 seconds to answer it, and then we'll give you all the answers. The first question is, if you ever have submetered or are submetering right now, what challenges are you facing? And select any and all answers that are available. Okay, and we have our first results. The challenges were financial justification was a big one. Value determination, interestingly enough. Complexity of system design and installation was also a big one. Fragmented delivery of the chain on hardware level and on fragmented delivery chain on analysis level. So great, thank you very much. Our next question right here, there we go. What new opportunities for energy savings have you identified from the data, presumably from your submetering installations? Okay, and we're ready for the answers. Okay, so they haven't helped you identify high energy use loads. Anomalies is another good one. Assessing system performance, affirming energy use reduction from implementing of energy. Okay, that's a very good one. And then verifying persistence of energy savings and measures. Okay, great, excellent. Next question, please. Would you like to connect directly with Meson after this call? Yes or no? Okay, so a lot of you said yes. Good. So we will, make these slides available. I said, and the contact information for both John and Stelios will be in the slides, and they will be able to follow up with you afterwards as well. I believe that was our last question of the poll, and if you're ready now, we can start with the Q&A. The first question that I noticed here, I think Anne would be really interested in answering questions that are deal with the specifications, what was required by specifications. I don't see any right now, but if those come in, we'll definitely send them all to you. The first question I have for John is, when will these be available for purchase in the U.S.? A search yesterday produced no viable sources, even in Greece, they said. You want to take that one on, John?
Yes, thank you, Bruce. The systems are available right now, and this is why we mentioned these trial packages. We actually have more installations in US. We're actually starting. As I said, in Europe, we are a lot bigger. And if someone wants to get in contact with us, this can be done through our website and the contact information. But also the emails that I just presented earlier on. Thanks.
Okay. And the next question also for you is, how is Meson distributing this product with field support? So presumably you've got representatives in the U.S. that help support it?
Yes, correct. Our strategy is the following. First of all, as Stelios also mentioned, our products can be maintained in a great percentage remotely and commissioned sometimes. Why? Because we have included in our gateway some capabilities in order to be able to really commission and support the operations of the system. Of course, we do need cooperation with energy services company, electricians, etc., in order to be able to do on-site support. The usual on-site support that we need is maybe a replacement, but maybe some testing rarely. In most of the cases, we can do that, as I said, remotely. So the only need is to be able to install physically the meters and maybe replace them.
Okay, great. And one more quick question for you, John. Is there a subscription for the cloud data system?
Yes, there is a subscription for the cloud data system. It is a yearly subscription per meter, which is 3-phase meter, and this subscription is 45 per year per meter. Of course, we have some value-based discounts. Depends on, I mean, if somebody gets, has a project with 1,000 meters, then the price will be different. This is something we need to discuss.
Okay. This may be a question for Anne. Could you describe the data storage capability on the winning unit, whether the intervals may be specified by the user?
Well, the specification did require some interval data, and it asked that the selectable data be 1 minute, 15 minute, or 60-minute interval data selectable. And then there was a requirement for storage. And 4 gig is what the requirement was for storage.
Okay, great. Another question here, and this may be more for Stelios. Why is the power limited to 63A, approximately 65 horsepower? We have 3-phase motors well below this size.
Muted. No, what I said is we start measuring from 63. This is the lowest model we have, but as I said, this can go to 1,000 ampere per phase. So this is just the smallest possible meter we can do. We can measure. We have versions at 63, 100, 125, 250, 400, 600, and then we go with Rogolsky coils to thousands of ampere. So we can measure all the devices. And of course, when I say 63, I mean 0 to 63. So 10 ampere, 20 amperes, it's within the accuracy we want to measure. I mean, the smallest model, has 63 as the upper limit.
Mm-hmm. Okay.
Of course, all of them measure from 0.
Okay. And another question for you, does the gateway have to be plugged in or connected to a computer in order to collect the energy data?
There is no need to be plugged in a computer or to the internet. It can be a standalone. Actually, this was the case in DOE. The data were transmitted from the meters to the gateway. Gateway stores data internally. There is a database where you can store data in different intervals as the user want to configure this to store data. And of course, when you connect, you can get the data in an Excel file. You can work with this data as you wish. If the device is connected to the internet, then of course it can transmit data to servers and wherever we wish to. We have to program this to send data somewhere.
Great, excellent, good. Is there a power factor or other metrics, or just kWh or kW that it measures?
As I said, it measures all the characteristics of a power line: voltage, current, apparent power, energy, frequency of the data. We don't measure only analytics if we compare it to, let's say, some of the devices that are high cost and they do this kind of things. We measure per phase all these parameters I mentioned.
Okay, excellent. Can you tell us some ways that this system might work without an internet communication network? In other words, can these devices collect data and store it on board that would then be available to download at a later time?
Yes, you configure your network. You have your meters. They talk to the gateway. You can put names on every load. As we said, the meter itself can have data logging inside, because let's say there is no wireless connection for any reason. So for 3 weeks, the meter can log data inside. When the wireless connection to the gate will be back again, these data will be downloaded to the gateway, and the gateway has a lot of space and the database there where we store data. And of course, we can extract these data in different file formats. CSV is the simplest way of doing this.
Okay, and one more question for you real quick is, how difficult is it to reconfigure the submeter if you want to move it from one panel to another?
The meter can leave from one network and join to another network. I don't think this is the problem. If we want to make it more technical, the discussion, this is a Zigbee network, and what we do, we ask the device to leave from one network and then join to another network, and then it will be part of the second network. As we said, in the gateway, we provide some tools that make all these things easy for the user and the installer.
Okay, very good. We have a few more questions real quick here, and I'll leave it to either John or Stelios to answer them. How can this wireless system be integrated into an existing metering software system and networks that are government system behind a firewall? So presumably if other government agencies want to install it.
I can take this. In general, as I said, the gateway is a Linux machine. So if we know what is the interface needed, we can support these things. We usually support interfaces like HTTPS or MQTT. We have implemented interfaces to, I don't want to say now specifically, but most of the known, let's say, cloud services available. They have, let's say, IoT extensions, and we were able to send data there through the authentication mechanisms and, the highest possible security. So there are ways to do this. We have implemented some of them. We can implement more things if needed.
Okay, very good. Another question that came in here is, can these systems be set up for residential use in conjunction with solar power panels?
Yes, actually, one thing that our meters can do, we have some features that we can distinguish energy produced from energy consumed. So if needed, we can see how much the time that the PV is generating energy and goes back to the system. We can separately measure these two things, so the meter can work very well in such an environment.
Great. Okay. Another question that came in, this may be for Anne, is the DOE looking to pilot this at other locations?
At this time, they do not have any specific plans for any pilot locations, but DOE is definitely interested in getting any information from folks that have had metering experiences. Their DOE always likes opportunities to look into possible case study development and such as that. So specifically as far as
Anne, this is Cindy from DOE. I just want to jump in and actually let everyone know that we are planning to host a pilot demonstration of this technology within a U.S. building, and that we will plan to do measurement and verification around that too. So that's all I'll say for now, but we'll definitely put that information out there and let everyone on this call, as well as the Meson folks, know about that too.
Great. Thank you, Cindy. Another question for John or Stelios. Is the gateway's demand response capabilities OpenADR 2.0 certified compatible?
Excuse me, the question again?
Let me rephrase it. The demand response capabilities of the gateway, are they compatible with the OpenADR standard 2.0?
OpenADR 2.0 is one of the first standards we were working. We don't have, let's say, a fully ready solution, but we have done a lot of work, so I think it will be easy for us to have the full, let's say, solution ADR2 ready.
Okay, very good. Is there a possibility of purchasing the analytics software with licensing that allows an owner to do monitoring and analytics in-house without continuous software as a service?
John may take this.
Yes, I can answer that. We have designed and and produced this system with the cloud monitoring in mind. On the other hand, we have developed some in-house tools that run on the gateway and give the capability to someone to have a look and see the consumption and see the data from the energy meters. This can be done either by using our energy gateway tool or some third-party tools that we are using, and they are really open. But it's not with the same user interface and the same experience. Yes, you can see it, but not that sexy.
Okay, very good. Thank you. We have a couple more questions. I want to try and get them in before the end of the hour. One question here is, has this meter been tested or piloted or used in situations in which existing buildings are subdivided into apartments, like in multifamily housing, or for businesses and need to be wirelessly submetered so they can communicate from the panel to a main?
Actually, this is the case of our, let's say, customer in Spain. There is a utility in Spain that uses our meter to do these things in a home environment, and now they move it to small enterprise environment. So yes, the answer is yes. It can be used in this kind of environments.
Okay. Another quick question here is, does your system work with water meters or all flow meters or with other outputs?
As I said, our system is based on Zigbee, and our effort was mainly on the energy part of this, but right now we try to integrate water meters or other sensors, let's say, not only water or gas meters, any other sensors Zigbee based can be easily integrated in our gateway. So the answer is yes, and if something is not, 100% there, we can easily add these things. We work on some extensions of the Zigbee standard for, let's say, sub-gigahertz radios, which makes this even more interesting because I think this is much closer to gas and water metering systems.
Great. Okay. And then the last question we'll get in is, have you tested this in data centers?
One of our customers is using this to measure actually a lot of data centers in Greece. He's monitoring the different things, and yes, the answer is definitely yes.
Great, thank you. All right, well, I want to go ahead and thank all of our panelists today. I want to thank the audience for attending, as well for staying through much of the presentations. Like I said earlier, this is going to be recorded, and the slides should be made available at a later date. Please feel free to contact us or the presenters. There should be a contact screen. There we go. If you have any questions, both for program support as well as on the technical side, either Stelios or John or Ann. We are going to have another series in the next coming year, so stay tuned. We're still fine-tuning all the topics, but we hope to bring you some more exciting topics and webinars that'll help you improve energy performance within your facilities. So with that, I'd like to wrap up and thank everyone, and we look forward to talking with you in the future.
Thank you very much, everybody, for listening to us.
Thanks.
Thank you.
Thank you.
Thank you. Bye.